Hello, and welcome to Lesson 1.3, Properties of Real Numbers. Our objective for today is that I can recognize the properties of equality and identity, and that I can evaluate numerical expressions by applying the inverse, identity, commutative, and associative properties. Today is going to be a very vocabulary-heavy day where I'm giving you properties and you are looking at examples of what that means. So let's start off with the reflexive property. What this means is that any quantity is equal to itself. So x is equal to x. 5 equals 5. When we get this in a solution, this is usually what happens when we are checking our work. We're going to get something like the 5 equals 5. And if that is the case, that means that our equation is true. The value we substituted in is truthfully the value that is the solution. Now, the symmetric property is just a way of rewriting things. So if one quantity equals a second quantity, then the second quantity equals the first. So for example, if we have x is equal to 5, we can also say that 5 is equal to x in that situation. So in this case, when we solve an equation, we get a variable on one side. It really doesn't matter which side the variable is on, as long as you have a variable is equal to a value. And that is what we're going to be looking for. Our next definition is the transitive property. If one quantity equals a second quantity, and the second quantity equals a third quantity, then the first quantity equals the third. So if we have x is equal to y, and y is equal to z, then we know that x must be equal to z. Even though we don't have anything there specifically showing it to us, we know by the transitive property that that must in fact be true. So identity properties, you can think of that and you can kind of hear a little bit of the word identical in it. So the additive identity property is that for any real number a real number is a non-imaginary number. You'll deal with imaginary numbers in Algebra 2. So for any real number a, the sum of a and 0 is just going to be a. So if we have a plus 0, it's going to equal a. Or if we look at it numerically, 5 plus 0 is still going to be equal to 5. Now, we're going to look at the multiplicative identity property. And what that means is for any real number a, the product of a and 1 is a. So we could have this 1 times x is going to be equal to x. But we can also look at this in terms of fractions, because the fraction 3 over 3 times x, we are still multiplying by 1, because any value divided by itself is 1, so that's still going to be just x. Now, where does this come in handy? This comes in handy when we are trying to change the denominator of a fraction so that we could have common denominators. We're going to multiply by 1 because we're not changing the value of that fraction. We are just changing the way it looks. So let's do actually an example like that. So if we had, 3 over 3 and we multiply it by 1/2, we're going to get 3 over 6, which we know reduces to 1/2. All we've done here is we've changed the way this fraction looks, all by multiplying by 1. So that is a very valuable use of the multiplicative identity property. So if we have identity properties, we also have inverse properties. And the additive inverse property says that a real number and its opposite are inverses of each other. What does this mean? Well, they're going to add to 0. So if we have 5 and we have -5, that equals 0. So additive inverses, they add to 0. So they're opposites. They are opposite signs. One of them will be positive, one of them will be negative. Now, the multiplicative inverse property for every real number, a over b, where a and b are not equal to 0, that's supposed to look like not equal to, but I couldn't find it on the keyboard. So a and b are not equal to 0, because one would make it 0, the other would make it undefined. There is exactly one number, b over a, that would make that an inverse. So we call this the reciprocal. The reciprocal. And you've used this in skills like cross multiplying. We've used this to clear fractions that are on a variable in a one-step equation. So we just have that a over b times b over a is going to be equal to 1. So for example, if we did 5 over 3 times 3 over 5, we're going to get 15 over 15, which is 1. Now, our next property that we're going to look at is the multiplicative property of 0. And what that says is, for any real number a, the product of a and 0 is 0. So 5 times 0 is 0. X times 0 is 0. So no matter what our value is, if we are multiplying it by 0, then our value is going to be 0, no matter what. We could have, x plus 3. We have this whole quantity is being multiplied by 0. It's still going to equal 0. So if we multiply by 0, it's 0. So now let's take a little bit of a logic leap here. If x times y is equal to 0, what does that mean about x or about y? Well, if they're going to be equal to 0, and we know that anything times 0 equals 0, we can say that either x or y is 0. And potentially they could be both 0, because 0 times 0 would still be 0. Okay. So we're going to move to the next page, and we're going to get the last two of our properties that we're going to look at today. The first is the associative property. The way you group 3 or more numbers when adding or multiplying does not change their sum or product. So, for example, if we do 5 plus 7, and then we add 6 to it, well, 5 plus 7 is 12, plus 6 is 18. Or if we do 5 plus 7 plus 6, that's still going to equal 18. Okay, so the way we group them does not change their sum, does not change their product. Because if we do 2 times 4 times 5, if we group it as 2 times 4 is 8, times 5 is 40. 2 times 4 times 5, well, 4 times 5 is 20, 4 times 5 is 20, times 2 is 40. So if we group them differently, it still doesn't change what we are multiplying. Okay, now we have the commutative property. The order in which you add or multiply numbers does not change their sum or product. So if we do 5 times 2 times 3, 5 times 2 is 10, times 3 is 30. If we do 2 times 5 times 3, we're still going to get 30. So as long as we are doing the same multiplication operation in a row, the order in which we do it does not matter. As long as we are doing the same addition steps in a row, the order of the values does not matter. As long as it's all addition, or as long as it's all multiplication, the associative and commutative properties apply, and it does not change the outcome of your response. Okay, so let's look at some examples. So letter A, this is back to, we are solving PEMDAS. So we have 2 squared, so we have 4 minus 2 squared is 4, plus 8 times 2 is 16. Well, those look like we have 2 additive inverses there. So those are going to cancel out, and you're left with 16. So those are additive inverses. Okay. If we look at letter B, we've got 3/2 times 2/3 times 7. So the 3 times 2 is 6. 2 times 3 is 6. Well, that's just the same thing, so that cancels out, and we're left with 7. So the rule that we're using here is the multiplicative inverse. Multiplicative inverse is the one that we are using there because we took the reciprocal. As we get further into the year, you can look at fractions too, and when we have just multiplication, we can see that we have a 3 on top and a 3 on bottom. Those cancel out. 2 on top, 2 on bottom. They cancel out. This is true when we are just multiplying terms together or multiplying fractions together. Okay, we have the exact same thing, top and bottom, so we can cancel it out. All right, so now we have one that I can just shortcut here because we could do 3 times 2 is 6, 4 minus 6 is -2, plus 7 is 5, but we're all multiplying by 0, so our value is going to be 0. So that's the multiplicative property of 0. So anything times 0 is going to be equal to 0. All right, let's just move down the page and look at letter F here. We've got 3/2x is equal to 6. So this is an application, and this is kind of diving a little bit into next chapter, but you should have seen this in 7th grade. So we have 3/2 x. So to get rid of that, we need to use the multiplicative inverse, and we need to multiply by 2/3 on both sides of our equation. Because what you do to one side of the equation, you can do to the other. And we'll talk about that more in a little bit. So we know that multiplicative inverse cancels out, and we're going to have x is equal to, well, we remember any of our whole numbers are a fraction over 1. So we have 6 times 2 is 12/3, and that's going to reduce to 4. All right, letter E, we're going to use just kind of an opposite property here. We're going to use that additive inverse. And that's how we are going to solve this equation, by using opposite operations. So we're going to subtract 4 from both sides of our equation. You'll notice I'm drawing a line. I'm showing my work. This is all things that you should do. 6 minus 4 is going to give us an answer of 2. Okay, now, if we go back to our previous chapter or previous lesson, we talk about ways to solve a problem that we should always go back and check our answer. If we substitute in 2 for x, 2 plus 4 is 6. That is a true value. All right. Now, if we have letter D here, are we changing anything with this or not? Because this, even though it's the square root of 3 over the square root of 3, those square roots are going to cancel out. So this would be a way that we could use to change a fraction. So when we want to rationalize a denominator, because we do not like radicals in our denominator, radicals are any kind of roots, we don't like them in the denominator, we would multiply by 1 to rationalize it. So we multiply by square root of 3 over square root of 3, but in the end, that cancels out, and we're just going to get 3/5 for this problem. Okay. Now, there are 6 U-Try problems here for you to do. I would like you to pause the video and go and work each of these problems. You might want to make note of what properties you are using as you're working them. And then go ahead and come back to the video when you are done and check your answers against the answers that I am providing. So if we look at letter G, I see that I have a multiplicative inverse here because I have 5/9 times 9/5. Those are inverses of one another, so they are going to cancel out because multiplicative inverse multiplies to 1. And now we're just left with 9 times 4. 9 times 4 is going to be 36. Looking at letter H. First, let's simplify inside of our parentheses. So we have 2 And we've got a bracket with 5 minus 15 divided by 3 inside the parentheses there. That's going to be 5. Well, you can probably see where this is going. 5 minus 5 is 0. And anything times 0 is going to be, you guessed it, 0. So this is the 0 product property, the multiplicative property of 0. Multiplicative property of 0. We'll use the 0 product property when we are factoring later on this year. Now, this is a one that looks a little bit weird because we have x being divided by 8, but another way that we can rewrite this problem would be 1/8 x is equal to 3. Because dividing by 8 is the same as multiplying by its reciprocal, which would be 1/8. So this is another one where we can use multiplicative inverse in order to solve it, and we're going to multiply both sides by 8/1. Okay, and we remember that a whole number is also just a fraction over 1. So if we multiply both sides by 8, we're going to get that x is going to be equal to 24. Now let's look down at letter L. We have x minus 5 is equal to 3. So to work this, we're going to use our additive inverse. So we're going to add 5 to both sides of our equation, and x is going to be equal to 8. Because negative 5 plus 5, those are additive inverses. They cancel out and they give us 0. And if we go back and check our answer, 8 minus 5 is 3, and that is true, right? So we can even use that other property. 8 minus 5 equals 3, so that means 3 equals 3. So by the reflexive property, we know that this is true. Okay, so that was using two different properties there to justify our solution. All right, letter K. We've got 14 divided by 2 times 5/5. 14 divided by 2, let's do the parentheses first. That's going to be 7 times 5/5. Well, 5/5 is 1. So we could do 7 times 5 is 35, divided by 5 comes back out to 7. And that is our multiplication property, that is our multiplicative identity property. So multiplicative identity property. We are multiplying by 1. It's not actually changing our value. All right, our last one here. We've got 5 times 12 minus, we simplify the inner parentheses, 3 times 4 is 12. 5 times 12 minus 12 is 0. 5 minus 0 is 0. And so that's the multiplicative property of 0. All right. Now, that was a short set of notes, but we are going to be applying these rules all throughout the year. So make sure you are familiar with them. Make sure you are familiar with what they do and how they can be used as we work moving forward. And you'll be able to be solving problems with no trouble at all. Thank you. Have a great day. If you have any questions, please feel free to reach out during class tomorrow. Have a great day.